Gracias, Mateo. Thank you very much. So it's time to talk about innovation, and we want to talk about innovation that will transform how we understand, we treat, and manage human health. We talk about innovation. I was thinking before, how should I introduce this session? And I was thinking on maybe some items, some bullet points that should bring this session. One could be 5 years endless disruption in terms of the amount of disruption and frontiers that have been explored through health. The second, where biology meets code. We could say that we've discovered tons of things connected to biology, to health, to treatments, from new drugs to digital twins to lots of things. And the last I was thinking on was predictive, personalized, and programmable. So in a way, we've seen how next-gen gene editing, synthetic biology, modular biomanufacturing, lots of technologies which are amazing. So all these, across with some experts in biotech, digital health, AI, and academia, is what is going to happen on the next 30 minutes. That's why I would like to ask to join me in the stage to Montse Daban, Arantxa Sanz, Anaís Garrell, and Marta Ivón. Please, join me to the stage.
Hi, I'm sorry, but I'm going to face the public, the audience. So thank you very much for inviting me one year more to this event. For me, it's the most disruptive event in Catalonia, in Europe. I don't know if in the world, but actually, Miquel, thank you for inviting me every year, because this is absolute disruption. This is what I intended. So what I did today, I'm Montse Daban. I am at Biocat, which is the life sciences ecosystem organization in Catalonia. And we always try to talk a little bit about technology and life sciences and health innovation. But this year, I asked my friend Tati to give me a suggestion for a code for the name of this session. And ChatGPT, I wanted something that looked like manga or something very, for young people, as you or all, for sure. So I wanted something very, very, inspiring. And it says, okay, Lifecode 5.0, the tech awakening. And I think we are in this tech awakening. But also a tagline, 5 years, infinite disruption. And this is where we are. We are building this infinite disruption. And for that, I wanted also two things. And Miquel always says yes to everything, so thank you, Miquel, for that. So I wanted to have only women on the stage, because I have the belief, and nobody's going to tell me no in 100 years, that technology is going to be feminine in the future. And the second thing is that the silos between sectors will blur. The boundaries will blur. So now we are talking about some things that might not be really, deployed or influential or really impactful in the current life sciences and health innovation ecosystems, but it will for sure in the next years. And for that, I asked my colleagues, I'm going to introduce them. I have here with me Marta Ivón. Marta Ivón, she will introduce herself. But Marta Ivón is CEO and founder, and I'm sorry because we are like very, are we just invisible here? But anyway. So Marta Ivón is the CEO and founder of Intelligent Battery Analytics, but she's an expert on AI. Her PhD is on AI, and she will talk a little bit about AI and omics for science. So those that are working on AI here and don't have omics in your span in the future, please take care, because this is going to be something. I also have here Anaís Garrell. Anaís Garrell is PhD in robotics. So what she's going to do is trying to tell us what will robotics mean in the future of life sciences and health. And then I also have Arantxa Sanz. Probably many of you know her. She's CEO of Catalonia.Health, and she has PhD on quantum chemistry. So I'm going to ask also Arantxa how quantum is going to be disruptive as enabling technology for healthcare, like we said. But first thing I'm going to ask them, of course, is to introduce themselves better than I can do for them, and also tell in 1 minute something that is really, really interesting, many things for sure, about their job, their work, their research, what they're doing. So their first statement is coming. Marta, please.
Hello, everyone. I'm Marta Ivón Cárdenas. My journey began in Havana, University of Havana, with the degree of Mathematics and Computer Science. And later, I did my master's and PhD in Artificial Intelligence at Universitat Politécnica de Catalunya, here in Barcelona. Currently, I'm doing research, mentoring, and academy. My main research focus on omics data, but not only on omics data, but also on energy data, emotional data, and so on. It's a heterogeneous data.
Thank you, Marta. I think that we can state that these women here represent the next generation of technology leaders, and for those that are wanting to be in the future as well. So please, at least Anaís and Marta were not very much involved in the life science ecosystem before. Many of us know each other, but I think this is a very good thing that they are with us today here. So Anaís, now your turn.
Thank you very much for being here. So I'm Anaís. I'm an associate professor at the UPC. On the one hand, I'm teaching how AI can be applied and embodied in robotics. And on the other hand, I'm the deputy of the Robotics Institute of UPC as well, where my research focuses on how humans and robots should interact in a natural way. We want robots to adapt to humans instead of humans adapt to robots. And also, we perform different algorithms and applying AI to make robots capable to collaborate with humans.
Thank you, Anaís. I think it is clear that this tech awakening will involve some of those technologies, probably more. And I would like to ask, probably at a certain moment, the audience, if you have other ideas that can be, gathered to these ones, forecasting the disruption that will come for life sciences in the next years. But now, Arantxa, you know quite a lot the sector, so please make the statement and introduce yourself.
Thanks, Montse. I don't know if I know so much. I'm Arantxa. I'm the current director for Catalonia.Health, which is the business association and cluster organization representing the whole chain in the health sector. But by training, I'm a quantum chemist, which means that I'm one of the few people in the world who maybe knew Oppenheimer for something else than Enola Gay. So it's quite exciting for someone who can, I can consider myself a knowledge broker across silos, to be here to try to shed some light on how the industries that I work for now to try to be more innovative are going to benefit for something that maybe was very distant to them as quantum.
Thank you, Arantxa. I think that we are very lucky to be in this forefront of science and technology, imagining what will happen in the next years and probably being able to really make it happen from our perspectives and our positions. So, but for that, we need to solve some challenges that these technologies still have. We all know, there's the question, is AI in a bubble in this moment? Is it going to be like something that is not complying with the forecast that we have? And for that, I will ask Marta, do you think which are the challenges? You are doing research on that, probably not really first line in health, but in other areas. But which are the challenges that we're facing at that level, and what you're doing to solve them?
Yes, there are many challenges, as you know, but the main challenge is, as omics is a data stream, for example, AI can be an interpreter, but accurately, because we are not an average. We need to personalize our...
What do you mean we are not an average?
Normally, the AI models set an average of accuracy.
So you mean that probably technology for health is facing particularities on that level?
Yes, it's necessary because every human body is unique. So our omics defines you. And then we deal with this data and has to be very precise, like personalized medicine, specifically for rare diseases. It's very, very sensitive.
And which is your research at that level, and also with the energy side, facing in terms of challenges? Which are the limitations that you find in the AI application?
In general, we need to detect these signatures that are useful for clinicians to target this concrete disease like Alzheimer, cancer, or cardiovascular disease, etc.
Good. So you mean that probably this is, the challenges that we are facing related to AI omics, and this AI is applied to several other things. For sure, this is going to blur the borders between these different sectors. In that case, Anaís, you also have the application of AI, but in robotics.
Yeah.
So something very particular, and we will talk about health later, but what is your vision on that? Challenges and solutions you're finding?
In robotics, we lived a change of paradigm 5 years ago with this explosion of AI, because now we are capable of putting all this knowledge inside the robot. And there are a lot of challenges that are already solved, but not quite of them. For instance, we have the challenge of understanding the world. For us, from being a child, we are learning how the world works, and we try to adapt to it. So with robots, it's more or less the same. They need, with its own sensors, they need to understand what is happening. They need to understand how people behave, and also the communication. You know that LLMs appeared like 3 years ago, like ChatGPT, and everybody's using it, so also robots. And with this, we have the opportunity to give the robots the capability of understanding and communicate naturally with humans, which is really a step forward to have robots in our days.
Which are the limits for the robotics and human interaction? Because I'm sure there are limits and we have to be aware of them.
Yeah, there are a lot of limits. Researchers, me included, are working on ethical issues, because first of all, we need to educate children. Robots will be a tool in our life days, and we need children to understand which are the limits. We as adults don't have these limits. So we need to start deciding what a robot can do and what a robot cannot do. For instance, something in Japan that is happening, they are looking for robots that are equal like humans. So you won't be able to distinguish between a robot and a human. This is something that in Europe, we don't like this idea. So maybe it can be a limit that we need to understand.
But do you think that in Europe, and this is a question also for Marta, in Europe we have strict regulation regarding AI and the use of robotics to modify? I mean, I heard someone saying a few days ago that there's one territory that should not be touched, which is human mind. Is this something that you see, in the future somewhere?
I think governments should protect us. And I know that a lot of committees are working on this topic, but we don't have the laws still to protect ourselves.
And which would be, Marta, the power of AI to because we all are receiving videos of ourselves that our friends send to us saying, okay, this is you, and it's scary, right?
Right, but we have to be careful also, because also we need to center the leading on the human and not on the robot. So we need to get the control.
Okay, and and just to finish with that part of your work with AI, tell us a little bit about energy. What are you doing in the energy? Because you are the CEO also of this company. What are you doing in that sense?
Yes, it's with the lot of energy data we can extract from electrical vehicle battery. We need to do a smart process, like a machine learning model, in order to detect which battery can be reused for second life applications, which is very important nowadays.
And you have customers in the automobile and eventually in the medical equipment, for example, that could be useful somehow.
Useful for portable energy equipment.
Okay.
Anyone, but photovoltaic applications are the most more popular, and also the Powerball at homes as well, and data centers, which are the main clients.
Okay. Okay, Arantxa, my son is currently on a master's thesis on quantum. Should I tell him that there's a future or not?
Of course. So in particular, when we have heard the ethical challenges, no? For instance, for robotics, I would say the good news is that the challenges for quantum computing are essentially technological or physical. Maybe because of that reason, we cannot go beyond them, no? Because the greatest enemy of quantum computing is temperature. So far, all the systems that we can think of, they have to be working at very, very low temperatures to actually stay quantum and to show the properties that we would like to see both in quantum software, quantum hardware, and the diverse systems that we can think that they could display this wonderful news. So I would say the challenge is about building up computers with a size that could help us with real problems, both in health or in any other applications like finance, industry, whatever, defense, of course. So I think it's a very different case, probably, especially to the case of robotics. So yeah, we are in the hands of people like the ones in photonics.
So, but one quick question. So tell us something that, I mean, it's a myth and it's not happening yet on quantum, because I think that many of us have the idea that quantum computers are almost there. We can choose to work with a quantum or with a traditional computing system. What is?
Well, the question is that there are some sort of like prototypes with a really reduced number of qubits. So imagine that instead of like the amazing number of gigaterabytes that we are used even in any sort of laptop or files that we're managing, you just would have 10. So obviously, even when quantum qubits are a lot more powerful, let's say, than classical implemented on silica chips bits, this means nothing. So in terms of what is of interest for pharma and for health, we are talking about experiments or models that maybe can simulate a 10 electrons reaction. So obviously this is something, and you can do that once and you can really repeat it. And so quantum right now is very prone to error, and it can really manage actual sizes. So basically it's not there. It's like the question about quantum is that we know the theory since 100 years ago, but the implementation is a huge challenge in terms of physics and engineering. So as long as we haven't got the actual machines with hundreds, 1,000 qubits corrected, which means many other uncorrected qubits being implemented in one of these things happening at ICFO, we won't be able to actually do this. So probably it's closer to the other challenges, but we would be thinking maybe in 1 decade or something like that.
Yeah, I mean, it's interesting because at different levels, I think that quantum can be a promise. And I'm going to ask that to you as well, in terms of helping us solve some resources challenges that we have currently for the computing sector. For example, I know that qubits now are being used, like, for example, aluminum or other materials. So in terms of materials, do you see that it's going to be like an advantage regarding what we are doing now with the traditional computing methods we have?
Yeah, so essentially, I mean, modeling any sort of interaction between biomolecules or biomolecules and a surface, like it could happen in, I don't know, microbial resistance, for instance, or any advanced material, any material, it's a quantum situation. So obviously a quantum computer can lead us to an exact solution, which is something that with the current classical computers, we just can't dream of doing something very, very approximate. So obviously it's a total change of paradigm of anyone involved in chemistry and materials engineering. Yeah? So in that sense, it's something like, it's very difficult maybe if you haven't done any quantum to imagine how one of these computers would work. It's something like, I don't know, one of my favorite films is Arrival. So it's very difficult to imagine super intelligent animals that happen to be calamari, or squids, or octopuses. So it's something like that. So some of the difficulties about envisaging how quantum computers would work is that we would have something, I don't know, maybe really small, embedded in something really cold, and maybe there's no internet, and everybody has to connect to that sort of, squid
I know.
somehow, and retrieve answers. So it's very different from the kind of like computing that we have got used to in terms of hardware. But yeah, for materials, it's something totally life-changing, that we will have immediate answers to how proteins are going to interact.
You already answered a little bit the question about how this is going to be implemented in life sciences, or which is going to be the impact in life sciences, which is something that I wanted to ask you next. But you are brilliant in the sense that you already answered. So thank you very much for being in this session today. I hope we have engaged some thoughts for the future, and thank you to our panelists for being keen to share with us their thoughts. Thank you very much.
Acció som l'agència pública de la Generalitat de Catalunya que facilita el creixement de les empreses catalanes. Però com?